Hey, so welcome to today's session. In today's session, we're going to be able to design a relational database in line with a client brief. So in our previous tutorial, we have defined a couple of aspects of database management system. So when it comes to database, we need to understand that a database allows us to store information, and what happens is that there is it is a combination of programming and the use of entity and relationship. So what does this mean? That in order for us to define our database, there are some requirements. So we need to plan our database. So we need to be able to make a design which allows us to have these entity and attributes communicating to each other. So what do we mean by entity relationship diagram? So this is simply a graphical representation of all the information that we have regarding our object. So as we mentioned, there are two types of database management system, which is relational and non-relational. So by non-relational, we mean that we store in all unstructured data, and we tend to use application such as MongoDB, which allows us to use non-SQL application, while when it comes to structured data, we are using SQL or MySQL. So yeah, depending on what we're working, if it is relational or non-relational, we need to create a diagram, a graphical representation, which shows what is the connection between the entities and our objects. So it defines what is the relation between all of these aspects. So therefore, before we now start using our SQL, we need to define them. So for example, a diagram can represent the information system for a shape cell, depending with the graphical representation. So for instance, when it comes to Amazon, where we need to collect payment online, we need to store this data in tables, which allows us to, which will now allow us to have our relationship. So we now need to plan this. There are loads of software which allows us to create relationship diagram, such as Draw.io or business process model notation. So there are different types of symbols when it comes to creating our table. And using this software, we're now able to see what they are. Also, we have data flow diagram. So this allows us to map out the flow of information from any process of a system. So it now uses defined symbols like rectangles, circles, and arrows, and also plot short table labels to show the data input and output, and also the storage point at the routers between each destination. So this is an example of DFD, where we have a starting point, we have a user, Then we have a flow, flow diagram, which shows us how these connect to each other. So these are some of the symbols that we can see. So we have external entities. The circle indicates that we're now processing, and a rectangle now looking into how we are storing this data. And then arrow will indicate in which direction the data is flowing. So we have now explained them. We have looked into how these are going to be done. So as we said, square, we're looking to an outside system that will send or receive data, which is now communicating with the system, which is being now diagrammed. Then the circle, we're looking to any process that change the data, producing an output, what might perform in a computation. Then we have data storage, which fills files or repositories that hold information for lateral use, such as a database table or membership form. Then, as I said, there is data flow, which is simply the arrow that will now route the data, which is taken from any external entities and now is processed and into the data storage. So what do we mean by data direction? By data direction, it is simply directionary about the data that we store in a database. So while those always contains information which are going to be regarding our object, such as entities and attributes, and all the information about our object, like table, columns, index, or control stains. So why do we need to understand why do we need all this information? See, all this can make it easier for us to identify and access our tables in a quicker way. So it is important to have security information. Who is the owner of the table, and when was this now created? So now it comes to planning a relational database design. So we have an example here below where we have a simple table with these entities and these attributes. As we can see, we have students, which are the attributes that are contributing into our table, and we also have some values that have been assigned for this. So as we can see from above, the example, everything is clear, the data. So what are the advantages that we look into when it comes to creating this type of databases? It will now give us a well-structured and clear information about our data, which it is a good advantage when it comes to validating and verifying our tables. Also, it is very helpful for our database administrator, which can now understand the data, our database, and it is easier for them to manipulate the information inside our data. Also, there are a couple of disadvantages which comes with this. The disadvantages could be it should be designed in advance to make all the advantages for it. And also it is cost effective, where the cost of the installation might be higher, and it will now require a lot of maintenance. And we're now looking into the composition. So what do we mean by the composition in the database management system, which is nothing but another name for our normalization. So when it comes to normalize a form in a database, which is simply the concept of which makes our relation or table free from our crude or our data manipulation. And it also anomalizes and saves space by removing duplication of data. So what happens is that we now decomposing our table in smaller chunks of table, which allows us to keep the information clear as possible. Here we have another example of decomposition, where we have our primary table at the top, and it is now subdivided into smaller groups in order for us to keep our data clear. So what do you mean by function dependency? Where it is simply a constraint between two sets of attributes in a relation from a database. So what happens in other words, functional dependency is a constraint that describes the relationship between attributes in a relation. So as we mentioned before, during the slide of our our previous slide, where we see this table, there are some of factors that define our schema. So there is at the top level we have attributes name, which goes for each column, and for our row we're now going to have our elements, such as the name of our object, last name, and all the data that has to be stored. When it comes to indexes, indexing the data is a data structure that improves the speed of our data retrieval operation on the database table. So indexing allows us to quickly access a field, a row, by simply adding an ID, which normally comes as a number, and it is a really fastest way for us to access our data. So what do we mean by contrasting? These are simply rules that the database enforce to improve data integrity. So we can now specify all of our following contrasting at either the column level or at the table level. Then we have unique contrastings, which are simply a first of column to contain only unique values. We're creating or alternating a table. You must define unique contrasting. Then we have referential contrasting, where it's the foreign key in a referencing table must always refer to a valid row, the reference table. So how do we check the constraint? The body of check constraint is a search condition. So we can now use a check constraint to make sure that the value is going into a column and meets the criteria of our searching conditions. So here are some of the values that we can now see into our table, such as not null, which means that we're starting from a value of not 0. Then unique, which is ensure that each row and column must have a unique value. Then we have foreign keys, primary and foreign keys, where a contribution of not null and unique ensure that our column or a combination of 2 or more columns have a unique identity, which help to define a particular record in a table more than easily and quickly. Then foreign key, which ensures the referential integrity of our data in a table to match the value in the other table. So what is SQL or SQL, which is simply used to communicate with our database? With SQL, we're now able to do some data manipulation, and we are able to make queries used to perform tasks such as updating, retrieving, deleting, and creating. So how do we design a query? In order for us to design a query, there are some factors to consider before writing the query. And the factors are what the query will do. For example, it's going to update, delete, retrieve, or insert. Then we're going to know in our data and how much the data expect to handle, where that data is, and accepted outcome. Then we have forms, where in a database context, a form is a window or screen that contains number fields or spaces to enter data. Also, with databases like SQL and Oracle, we now use built-in form, where they are going to employ the query option for data creation and manipulation instead. Design the form, we need to define some things. So what is the form required to do? Which table will now the form make a change? With the creation, what information need to be manipulated? And also other factors such as connecting the form to database table, how to create a label, text area, arrange and art style to text the form. So database design, we also do have macros, which is a tool that allows us to automate tasks and add functionality to our forms. Then we have security levels, which refers to collective measure used to protect and secure a database or database management software from illegitimate use and manipulation threat. Then we have denormalization, which is a strategy used on a previous normalized table to increase performance. So the idea behind is to add redundant data where we think it will help us the most. So this was everything for today's session. Is there any question?
There's no question.
So that's everything. Thank you for joining, and I'll see you tomorrow.
Okay.